Hey friends. Okay, so today we're going to dive into a few new things around radicals. In our first lesson was kind of meant more as an introduction, kind of reviewing the simplifying radicals notion that we did in 10C. We talked about writing as an entire radical, also something that was covered in 10C. The one thing that was not covered in 10C that we kind of added to you in that first lesson was just dealing with variables as well. So how to tell what a perfect square is when you're dealing with a variable, or how to tell what a perfect cube is. You know, we talked about the fact that every multiple of 2 for an exponent would be considered a perfect square, right? So x to the 2 is a perfect square, x to the 4, x to the 6, x to the 8, and so on. Any multiple of 3 would be a perfect cube. So x to the 3 or x to the 6 or x to the 9 and so on. Okay, what we want to do today is radical addition and subtraction. Now, this is very, very similar to, if you go back to grade 9 for a second, you were introduced to the concept of polynomials and really this concept of adding like terms, okay? I could add a 3x and a 5x together. If I had a 3x over here and I had a 5x over here and I put them together, I would have 8x. I hesitated there because I forgot the two numbers I had given you, not because I can't add 3 and 5. So if I had 3x over here and 5x over here, I would put them together and I would have 8x. But if I had 3x over here and I had 5y over here and I put those together, all I can say I have is 3x and 5y, right? I can't actually combine those statements because they're not like terms. It's the same thing with radical addition and subtraction. I can't combine them together unless the radicands are the same. Okay, so if the number underneath the square root or the cube root or whatever is the same, then I could put them together. So like a 2 root 2 plus a 3 root 2, when I put them together, would be a 5 root 2. Okay, but a 2 root 5 and a 3 root 7, when I put those together, there's nothing I can do. I would just have to leave it the way it was. Okay, so that's what we're going to do today. And a lot of this actually will just be a review of what we did in the last lesson, because a lot of this is just you simplifying radicals, okay? All right, so simplify the following expressions. We're just going to do this as kind of a warm-up. Identify the values of the variables for which the radicals represent real numbers. So we got to deal with that if we have variables to deal with. In this first example, there are no variables to deal with, but I want to look at this 75 and I want to say to myself, okay, I need a perfect square factor of 75. I know 75 is 25 times 3, so I'm going to break this down into 3 root 25 and root 3. Okay, that 3 in the front is just along for the ride right now. He just stays in the front. Okay, and then I ask myself, okay, what do I know? I know that the root of 25 is 5. So now on the outside, that becomes 3 times 5 because I know that the root of 25 is 5. Okay, so 3 times 5 is 15. So I end up with 15 root 3. Okay. Okay. Now, I've got the root of c cubed times d squared. Okay, I have to immediately think about where can c be defined and where can d be defined. I'm taking the square root. C is to an odd exponent. So that's that magical combination where I have to say, okay, hold on, c can't be anything I want. C has to be greater than or equal to 0. D, on the other hand, can be anything I want because it's squared, right? And that means even if I put in a negative number for D right now, the very first thing I'm going to do is square it. And when I square it, it becomes positive. So I will never end up taking the square root of a negative number there. Okay, so just off to the side here, I thought I would have done that first. Sorry. I want to say C is greater than or equal to 0. And D is a member of the reals. Okay, so C is greater than or equal to 0, and D is a member of the reals. That kind of looks like really, really spooky writing. Sorry, I'm not the best with mouse writing. Okay, so then what I did was I separated it into my perfect square piece and my leftover piece. Okay, I knew that from C to the 3, I could take out C squared, and D squared, I could take it all out. So my perfect square bit there on the left right here is c squared d squared. My leftover bit is root c. So now I have to ask myself, okay, what's the root of c squared d squared? Well, what's the root of c squared? That would be c. And what's the root of d squared? That would be d. Okay, so I end up with cd root c. Okay, cd root c. Good. Okay. Then I've got the cubed root of 24 q to the 5. Again, the first thing I want to do is talk about when the variable is defined. Because this is a cubed root, anything goes. I can take the cubed root of a positive number, and I can take the cubed root of a negative number. So I'm just going to say q is a member of the reals. Okay. And then I've got my perfect cube bit that I'm going to start with, and my leftover bit that I'm going to end with. Okay, so from 24, the perfect cubed bit would be 8. Remember, the process here stays the same. The only thing that changes is your list, right? Now you're looking for those perfect cubes. So you're looking at 8, and you're looking at 27 and 64 and 125 and 216, that list that you all memorized diligently for me, right? Yay. Okay. So 8 is the one that works here. When I have q to the 5, I could take out a q3, q to the 3, and then my leftover bit would be, well, after the 8 gets taken out, my leftover bit would be 3. 8 times 3 is 24. And after the q to the 3 gets taken out, my leftover bit would be q squared. Okay, so I end up with, just gonna clear my ink there so you can see my typing, which is way better than my writing. So I've got cubed root of 8q cubed times the cubed root of 3q squared. Now, I know the cubed root of 8q cubed. That's very hard to say. And that's going to be 2q. So I've got 2q cubed root of 3q squared. Okay, 2q cubed root of 3q squared. Okay, and then I have a fourth root. Okay, so I have a fourth root, and I'm looking at a w to the 10. I've got an even root index, and I've got an even exponent. Okay, so there, w can be a member of the reals, because no matter what I put in for w, as soon as I take it to the 10, that will become a positive answer. Okay, so w is a member of the reals. I need my fourth root piece and my leftover piece. Now, again, the process doesn't change. The difference is the numbers I'm looking for. So 2 to the 4 is 16, 3 to the 4 is 81. Okay, and right away I can see 81 is the one I want, right? So I'm going to put the fourth root of 81 out front. And then as far as w to the 10 goes, I could take out, you have to think it would be multiples of 4. Every w to the 4 would be a perfect fourth, right? So that's, I could take out w to the 8 essentially, because that would be 2 w to the 4s. Okay, so in my perfect fourth section, I'm going to have 81 w to the 8. The 2 is still in front along for the ride. And then in my leftover bit, I'd have w squared. Okay, so now I have to figure out what that is. The fourth root of 81 is 3, and the fourth root of w to the 8 would be w squared. So that's going to give me 2 times 3 is 6, 6w squared. Okay, just in case I lost you there, the fourth root of 81 was 3, and then I went 3 times 2. That's where that 6 comes from. And then the fourth root of w squared. Okay. All right, good. So adding and subtracting radicals is what we're going to head to today. Adding and subtracting radicals is very similar to adding and subtracting polynomials. I kind of opened my little talk with that. We can only add or subtract like terms. For radicals, in order to be like terms, both the radicand and the variable part of the coefficient must be the same, okay? Also, the root index must be the same. We can always verify our answer by using our calculator, right? When you're trying to do these things, if you type in the original question and look at that decimal response you get, and then you type in your final answer and look at that decimal response you get, you should get the exact same decimal response. If you do, you've probably done it decently well. If you don't, you need to go back and check your work, okay? All right, so we're gonna look at 8 root 3 plus 4 root 3 minus 5 root 3. Well, that's like 8 apples plus 4 apples, take away 5 apples. Okay, 8 plus 4 is 12, 12 minus 5 is 3. I'm left with 7 apples, but the apples aren't apples. It's 7 root 3, okay? All right, So what about this guy? None of these have the same radicand, so it must mean I can't do anything, right? No, we have to simplify everything first. Okay, so the first thing I'm going to do is I'm going to walk you through simplifying each one of these terms. Then we're going to look at what we really have. Okay, what we really have is kind of hidden right now because it's not in its simplest form. So root 48, I know that root 48 is root 16 times root 3. Again, I'm just looking for perfect square factors, right? 4, 9, 16, 25, 36, 49, 80, 64, 81, and 100. I have that written down on the side of my work so that I can verify, or I can use that list to help me try and figure out which one of them would be factors for what I'm looking at. So root 48 is root 16 times root 3, and then I know that root 16 is 4, so that becomes 4 root 3. Okay, root 180, I'm pretty sure that's a 36. I think that's 36 times 5 if my brain serves me correctly. It is. Okay, so root 36 times root 5, then I know that the root of 36 is 6. So I can change that to 6 root 5, okay? As I continue my simplification process, I'm also going to distribute that negative sign to both of these terms. So this is going to be negative root 12 that I'm simplifying, and then it'll be negative 6 root 45 that I'm simplifying, okay? So I've got root 12 would be 4 times 3, and that would be 2 root 3. So I'm going to subtract 2 root 3. And then here, 45 would be 9 times 5. 9 would, I could take the root of 9, which would be 3. So I end up with a 3 times 6 on the outside. So that would end up being 18. So I have my simplified version. I haven't done any addition yet or subtraction, but my simplified version would be 4 root 3 plus 6 root 5 minus 2 root 3 minus 18 root 5. Now I say, okay, what can I combine? What are like terms? Well, my 4 root 3 minus 2 root 3, that I can put together, and that would be 2 root 3, right? 4 apples minus 2 apples is 2 apples. And then my 6 root 5 and my negative 18 root 5 can get put together. 6 minus 18 would give me negative 12. Okay, so my final answer here would be 2 root 3 minus 12 root 5. Okay. Okay, same thing. The game changed slightly only because I'm throwing cube roots at you instead of square roots. You guys are pros at this now. The only thing that happens is your list changes. So now I'm looking at the cube, perfect cube list. I see that cubed root 16 could be broken down into the cube root 8 times cube root of 2. Oh, I want to hide that for a sec. Sorry, I didn't. I want to hide it. Okay. I want to walk you through it all before I show you. I thought I was going to go step by step like I did in the first example. Okay, so let's talk here. We'll start here. This is going to be the cube root of 8 times the cube root of 2, right? So cube root of 8 times the cube root of 2. Okay, and I have that in the next line to show you. 54, that would be 27 times 2. So I'll break that guy down into the cube root of 27 times the cube root of 2. And then the cube root of 250, I'll break that into 125 and 2. So cube root of 125, cube root of 2. Okay, so that's going to give me this. Okay, now I look at this and say, okay, what do I know? Oh, just as a reminder though here, make sure, I know I've said this at other times, but if you're dealing with cube roots, take note, every one I wrote has a cube root in there. Don't drop those cube roots. That's really, really important in your communication. Okay, so the cube root of 8 is 2. So now I'm going to get 2 times 8. So that'll be 16. The cube root of 27 is 3. So now I'm going to get 3 times 4. So that'll be minus 12. And the cube root of 125 is 5. Okay, so that's where I'm left off here. Now it's at this stage where I'm going to say, okay, can I combine anything together? And yes, I can combine them all together because they all have the same radicand. So I'll have 16 minus 12 is 4. 4 plus 5 is 9. So I end up with 9 cube root 2. Okay, 9 cube root 2. You're doing great, friends. Okay, so now we're going to keep going with this. We're going to do a few more examples, but now we're going to throw in some letters as well. Okay, so the only thing that changes as far as our process goes is we do need to have that conversation at the beginning of each question What are my variables allowed to be, and how do I write that? Okay, how do I communicate that to the reader? So we've got the root of 20x cubed minus 3 times the root of 45x cubed. We're dealing with a even root index and an odd exponent. So right away that tells me, okay, x can't be anything I want. X has to be greater than or equal to 0. So I need to state that in the question. X is greater than or equal to 0. Okay, now I'm going to work on simplifying. I'm going to split this up into my perfect square bit and my non-perfect square bit. My perfect square bit for 20x cubed would be 4x squared, and my leftover bit would be 5x. Here, I've got a minus 3, and then my perfect square bit would be 9x squared, and then my leftover bit would be 5x, okay? So now, I write what I know. I know that the root of 4x squared would be 2x. So this will be 2x root 5x. And then here, I know the root of 9x squared is 3x. And then I'm going to multiply that by the negative 3 here. So this will be minus 9 altogether. I'm just going to get ink back on there. So when I multiply these guys together, I'll have minus 9x root 5x. Okay. So then I can combine like terms. I need to make sure when I combine like terms that everything after the coefficient is exactly the same. So that's x root 5x. This is x root 5x, okay? That means those are like terms. I can put them together. It's just like adding apples. I've got 2 apples minus 9 apples, except that doesn't really work with apples because I would end up with negative 7 apples. You can think about that later. We're going to end up with negative 7x root 5x. Okay, negative 7x root 5x. Okay, good job. All right, so same thing, just a little messier. 5 root of x, or 8x cubed plus 4y root of 75y cubed minus 2 root of 27y to the 5 minus 3x root 50x. Now, again, I have even root indices. And I've got odd exponents on both x and y. So both x and y are going to have to be greater than 0. So x is greater than or equal to 0, and y is greater than or equal to 0. Now, I'm going to go through step by step each one, and I'm going to simplify. So root of 8x cubed, I'm going to split that into 4x squared, and then 2x. Okay, my perfect square piece and my leftover bit. 75y cubed, I'll split that into 25y squared and 3y. 27y to the 5, I'll split that into 9y to the 4. 9 would be my perfect square factor there. And then that would leave me with 3y on the leftover bit. And then 50x, I can take out a 25, and I'd be left with 2x. Okay, so that's what all of that would look like. Now, I'm going to go ahead and say, okay, the root of 4x squared is 2x, and then when I multiply it by the 5, that'd be 10x. The root of 25y squared is 5y, and when I multiply 5y by the 4y, that would be 20y squared. The root of 9y to the 4 is 3y squared. When I multiply that by the negative 2, that'd be negative 6y squared. And then the root of 25 is 5. When I multiply that by the negative 3x, I get negative 15x. Okay, so that's what I'm looking at here. Now, for like terms, I'm going to say, okay, 10x root 2x and negative 15x root 2x. 10 minus 15 would be negative 5x root 2x. Then I have 20y squared root 3y minus 6y squared root 3y. That would give me 14, 20 minus 6, right? 14y squared root 3y. Now, I'm going to put the 14y squared root 3y as my first term, only because it's a higher degree than x, okay? So 14y squared root 3y minus 5x root 2x, okay? Yay! You do this for hours and hours, eh? You should do this for hours and hours. Okay. Cubed root of 27x squared minus the cubed root of 8x squared plus the cubed root of 64x squared. Those are cube roots, so there's no restrictions on what the variable can be. So I just say x is a member of the reals. Then I would want you to recognize, because you've been doing so much practice memorizing your perfect cubes, 27, 8, and 64, those are all perfect cubes. X squared, I haven't reached a perfect cube as far as the variable goes, so they'll all remain x squared underneath the cube root sign. So I'm going to end up with 3 cube root x squared minus 2 cube root x squared plus 4 cube root x squared. Okay. The cube root of 27 is 3, cube root of 8 is 2, and the cube root of 64 is 4. So now I've got 3 minus 2 plus 4, which would be 5 cube root of x squared. Okay. Just like with polynomials, when you're adding like terms here, the radicand doesn't change. Okay. All right. Awesome. Let's try cube root of 16v to the 5 plus cube root of 3w to the 4 plus 2w cube root of 24w plus 5v cube root of 54v squared. Now, again, I'm dealing with cube roots, so there are no restrictions. I just say that v can be a member of the reals and w can be a member of the reals. Okay, I'm going to split myself up into my perfect square bits and my non-perfect square bits. For 16v to the 5, sorry, I said perfect square, I meant perfect cube, that was my bad. So I'm going to have the cube root of 8 v to the 3 times the cube root of 2v squared. Over here, I can take out w to the 3, so I'll have cube root w to the 3 times cube root 3w. Here, 24, I can take out an 8, so I would have cube root of 8 times the cube root of 3w. Okay, then on the last guy, I've got the plus 5v, the cube root of 54v squared. 54 is 27 times 2, so I'll break that into the cube root of 27 times the cube root of 2v squared. So that's what I've got going on right here. Now, with each of these, I'm going to say, hey, what do I know? I know that the cube root of 8v cubed would be 2v. So this is going to be 2v cubed root of 2v squared. Over here, I know that the cube root of w cubed will be w. So this will be w cubed root of 3w. In this third guy, I know the cube root of 8 is 2. So then I'll multiply that by the 2w. So this will be 4w cubed root of 3w. And then in the last guy, I know the cube root of 27 is 3. That'll get multiplied by the 5v. So that'll give me 15v cubed root of 2v squared. Okay, and so that's what I've done here. The last thing I need to do is just combine like terms. So I've got my 2v cubed root of 2v squared and my 15v cubed root of 2v squared. I can combine those together to be 17v cubed root of 2v squared. Then I've got my w cubed root of 3w and my 4w cubed root of 3w. I can combine those together to get 5w cubed root of 3w. Okay, so my final answer there will be 17v cubed root of 2v squared plus 5w cubed root of 3w. Okay, yay. A square with an area of 24 centimeters squared is placed beside a square with an area of 50 centimeters squared. In simplest form, write a radical expression for the perimeter of the shape shown. So the perimeter would be the distance all the way around. Now I would want you to be decently comfortable saying this one is going to be my 24 and this one's going to be my 50. Okay, obviously because the orange one's bigger than the blue one. So first thing I want you to say is, okay, if this is 50, every one of these sides of that square would be root 50. Now, every one of the sides of this square would be root 24 too, but I'll deal with that in a sec. What I'm going to do first is I'm just going to mark my root 50s. Okay, so every side of this square is root 50. Now, I want to try and make this as easy as possible on myself. So here's the next thing I'm going to consider. I'm going to consider these two portions here. Do you agree that if I added this piece and this piece together, I would have root 50? okay, I would have that whole thing. So I'm going to say that the perimeter is actually 4 root 50s. And then all I need is this piece here and this piece here, which is 2 root 24. So again, I'm ignoring this side because I included it by saying 4 root 50, okay? Because I had a root 50 here, that's this piece plus this piece. So 4 root 50 takes care of, essentially, if you can follow my mouse, here and here and here, as well as here and here, okay? Then I've got that 2 root 24 for my missing two pieces here. So perimeter is 4 root 50 plus 2 root 24. Okay, then I'm just going to simplify that. So root 50 is root 25 times 2. So that would be 20 root 2. And then 24, root 24 would be 4 times 6. So root 4 times root 6. Root 4 is 2, and then 2 times 2 is 4. So the final answer would be 20 root 2 plus 4 root 6 centimeters. Okay, 20 root 2 plus 4 root 6 centimeters. Now, I've posted your homework for this, and I want to encourage you to make sure you're doing as much practice as you can. Make sure you check your answers, but don't just write the answer key, right? If you just write the answer key, you're not really learning anything. Let yourself struggle a little bit. That's how those wonderful connections in your brain get made, okay? It's made in the struggle. So let yourself struggle a bit, do the practice, check your work, connect with me if you have any questions, okay? You got this. I will see you guys soon, and we'll talk about multiplication of radicals next. Take care, guys.